Dear students, I am Dr. Rajiv Sapre. This is lecture number 49 about metric topology. You know that currently we are working on sequences in metric spaces. From this lecture onwards, I will try to use OneNote for writing the things instead of Paint that I was using. This will help me to keep the record of whatever is taught, because I need not erase the things now. This can be continuously used. Okay. So we know in previous lectures what is meant by, just I will revise what was done. I will use black ink for this, or this other color I will use. So we know what is meant by sequence is convergent. This we know, right? What is meant by sequence is convergent? That means whenever you take a metric space x comma d, and suppose xn is the sequence in x, xn is sequence in x. Basically, what is sequence? That also I have told you. Sequence is any function from set of natural numbers to this metric space x comma d. And the method of denoting the set is just you enclose the nth term in the bracket. So xn is sequence in x. What you mean by this sequence xn converges to x? Actually, what does this mean? Every sequence has infinitely many terms. But apart from some finite terms, all the remaining terms will be close to x. And this close to x, we express this idea by using epsilon k concept. It means what? For any epsilon greater than 0, or we can say for each epsilon greater than 0, there exists k belonging to set of natural numbers such that distance between xn and x is less than epsilon for all n greater than or equal to k. What does it mean? From this step onwards, kth term पासून पुढच्या सर्व टर्म्स, पुढे सर्व म्हणजे किती टर्म्स असणार? Infinitely many. All of them are very near to x, because epsilon is our choice. For any epsilon, it can be very small positive real number. Still we are saying distance between xn and x is less than epsilon. It means terms of the sequence are such that from some particular kth term, all the terms following kth term, they are such that distance between xn and that the term where the sequence converges, x, it is negligible, right? Now it is not necessary that means what we can say, distance between xn and x is less than epsilon, means what we always say, if you are using say real number set in this, your metric space is suppose r comma d, then this dxn x will be changed to mod of xn minus x. That is what we studied in real analysis. If it is in R2, you can say norm, and it all depends on what is the metric which is defined on that metric space. Now you know this. Another concept I have discussed in previous lectures, it is bounded sequence. What is bounded sequence? We know that whenever you talk about sequence, it is a function. And function, when you consider, there is something called domain, range and all those things. Domain, codomain, range and all that. But what we are interested in, bounded sequence, actually what is meant by bounded sequence? It is a sequence whose range set is bounded. Bounded sequence whose range set is bounded. Range set is bounded. Right? You can take simple examples. We have already discussed that. Suppose we take this sequence, this metric space r comma d, where d is usual metric. You know what is meant by usual metric. Usual metric means dx comma y is mod of x minus y. And if you consider sequence in R, say it is 1 upon n, this sequence when I consider, What is range set of this sequence? Range set means what? You write down the terms of the sequence as a set. So it will be 1, 1 upon 2, 1 upon 3, etc. Right? This will go on. 1 upon n will be the general term and so on. Now you can easily observe that this sequence, this set is bounded. Why bounded? Because every term is positive and every term is less than or equal to 1. So here what I can say, 0 is less than xn is less than or equal to 1 for all n belonging to capital N. Right? So terms of this sequence, they are lying between 0 and 1, so it is a bounded set. This set is bounded, so range set is bounded, that means sequence is bounded. But in general, whenever I am not talking about R, I am talking about x comma d. And what is meant by set is bounded in a metric space x comma d? You know its diameter must be finite. So suppose I take A, so let A be subset of x comma d, subset of x comma d. Then A is bounded, okay, then A is bounded if and only if diameter of A is finite. Diameter, you know, diameter is what? If you take a set A, what is the diameter of A? Diameter of A is, what is that? Diameter of A. Already we have done, it is supremum of distance between x and y, where x and y both belong to A. Means for all x and y belonging to A. So whatever possible pairs you can get of x and y from the set A, calculate distance between them, and then supremum of that set will be the diameter of the set A. If the diameter of set A is finite, what is the diameter of natural number set? It is not finite. So natural number set is not bounded. Set real numbers not bounded. But if you take closed interval 0, 1, then it is bounded because its diameter is 1. Right? If you take closed interval 0, 1 as your set, then what is the diameter of this set? Maximum distance, whenever I take x and y belonging to closed interval 0, 1 and calculate distances between such all possible pairs, you will definitely get maximum distance at whenever x is 0 and y is 1. And that means what is the distance between 0 and 1? Whenever you consider usual metric, it is 1. And that is why this is a bounded set. Okay, so bounded set. Bounded set, why? Because its diameter is finite. But instead, suppose I take closed at 0, open at infinity, this subset of R when you take, you cannot find its diameter. Right? So this set is not bounded. So I hope you understand what is meant by set is bounded, what is meant by set is not bounded. So now we are going to relate convergence of the sequence and boundedness of the sequence. So you must understand these concepts first. That is what we have written. What is meant by sequence is convergent, that is written here. And what is meant by sequence is bounded, that is also written here. Sequence whose range set is bounded. And what is meant by range set? All the terms of the sequence you write as a set. If that set is bounded, sequence is bounded. Set is not bounded, sequence is not bounded. That is what we should know about this concept. Now we are going to proceed further. तेव्हा आतापर्यंत जे झालंय या लेक्चरमध्ये ते पुन्हा नीट वाचा, त्याच्यावर विचार करा आणि मग पुढचं काम करायला सुरुवात करा. यू कॅन पॉज द लेक्चर आणि बघू शकता, आपण पुन्हा ते ऐकू शकता पहिल्यापासून. ठीक आहे, तर आता एक महत्त्वाचा रिझल्ट आपण प्रूव्ह करायला जाणार आहोत. इट इज लाईक दिस, दॅट एव्हरी what we can say convergent sequence is bounded. Every convergent sequence in a metric space is bounded. So this is the theorem that we are going to discuss now. What is the theorem? Every convergent sequence, CGT I am writing for convergence, convergent sequence in a metric space is bounded. BDD is the short form for bounded, CGT for convergence, etc. So every convergent sequence in a metric space is bounded. This is what I have to prove. So what will be the proof? Right? It is very nice proof, nice development. So what we will do is, we will start with some convergent sequence. Here we have not to prove that sequence is convergent. Every convergent sequence, so you are given that sequence is convergent. So let xn be convergent sequence in a metric space, x comma d. Now as it is convergent, it will converge to some point. Okay, so let xn converges to x. Suppose xn converges to x. Okay, so what we will prove is this. We will prove that there exists r greater than 0. We will prove that there exists r greater than 0 such that xn belongs to Sxr. Now when you know all the terms, we will prove that there exists r greater than 0 such that xn belongs to Sxr for all n belonging to capital N. What it means? All the terms of the sequence belong to this open sphere. Now this open sphere has a radius r, so its diameter is 2r, and so diameter is finite. So when all the terms of the sequence are in the set whose diameter is finite, definitely sequence is bounded, because that set will be bounded because its diameter is finite. So this is the logic behind the proof. So okay, now what is given? How you will prove? As xn converges to x, this is given to you, xn converges to x. So use the definition for every epsilon greater than 0. So we choose epsilon as say 1. Now this, when xn is converging to x, for every epsilon, that result that we talk about convergence, the definition is true for every epsilon. So I take deliberately epsilon as equal to 1, right? This is 1. Okay, so what I can say, for epsilon is equal to 1, there exists say k belonging to set of natural numbers such that distance between, okay, I will write it here, such that distance between xn and x will be less than 1 for all n greater than or equal to k. Right? There exists k belonging to n. What do you mean by this statement? What you mean by this statement is, suppose my sequence has the terms, I will write it here. This is just an explanation of what I want to say. Okay, this is just explanation of what I want to say. See, what I want to say is this. What do you mean by all this? Your dxnx is less than epsilon, less than 1 for all n greater than or equal to k. Terms of the sequence are what? They are x1, x2, etc. Somewhere it will be xk and so on. This is your sequence xn, right? These are the terms in that sequence. Now what we are saying by this, distance between xn and x is less than 1 for all n greater than or equal to k. So from this term onwards, whatever remaining terms are there, they are lying in the ball centered at x radius 1. So what this implies, what this statement implies is xn belongs to Sx1, okay, for all n greater than or equal to k. I hope you understand this. Whatever we are saying here is equivalent to this. So the question is remaining terms. What happens to them? Right? We know now that from kth term onwards, whatever are the remaining terms, about those terms, what is true? All those terms lie in this open sphere whose radius is 1, center is x. Now what you do is calculate, consider the remaining terms. Remaining terms are important for us because sequence means these are not the only terms from k onwards. Remaining terms also are important. Okay, so what we will do is we will calculate distance of the remaining terms from x. That means consider dx comma x1, then what, dx comma x2, etc. up to dx comma xk minus 1. What is done here? I have calculated distances of the remaining points. Remaining means which? x1, x2 up to xk minus 1 from x. Okay, now suppose, so these are some distances, right? So I will say that this is say distance r1, this is say distance r2, this is say distance rk minus 1. Now what you do is let r is equal to maximum of all these things, 1, then r1, r2, etc. up to rk minus 1. I will take r as maximum of all these, 1, r1, r2, rk minus 1, etc. Right? Then what will happen? Then what we can say here is कि dx1x, dx1 comma x will be less than or equal to r. Then dx2 comma dx comma, sorry, what is something wrong here, dx comma x1, dx comma x1 is less than or equal to r, dx comma or here we can say x2 comma x is less than or equal to r, etc. dxk minus 1 to x, this is also less than or equal to r. Okay, so in general now what I can say, and after this what is happening, dxnx is less than 1, but 1 is also included in this set. So what I can now say is also dxnx is less than or equal to r for all n greater than or equal to k, and up to k also here it is, each term is less than or equal to r. So now if I combine all these things, what I can say now, ki for all xn, for all n belonging to capital N, so this implies we can say for all n belonging to capital N, distance between xn and x is less than or equal to r. What does it mean? xn belongs to sxr. Actually now here it is less than or equal to r, so we can say xn belongs to x, closed ball we can take, xr. I will erase this and write it properly. So see, we are taking less than or equal to r, no, so it should be closed ball. So xn belongs to sxr. In short, what happens here? This is a closed sphere whose radius is 2r, sorry, whose radius is r, so diameter is 2r. So this is a bounded set and all the terms of that sequence belongs to this. As this is bounded, the sequence is bounded. For all n belonging to capital N. So sequence xn is bounded. I hope you understood whatever I taught. And what we can say here, so every convergent sequence, so finally conclusion is convergent sequence is bounded. what we can do here is, instead of saying r is equal to maximum, you can take r greater than, some value greater than, or you can calculate r is equal to maximum of all this, and once you do, or you can take here r dash. Suppose r dash is maximum of 1 up to rk minus 1, then you can write r is equal to r dash plus 1, and then this will be less than r, and then this will be open sphere and all that, so we'll follow. So but then anyway, what we have proved is every convergent sequence is bounded. Now the question is the converse true? Always remember, whenever you prove one way, this is not if and only if statement that we have proved. So immediate question that should come into your mind is whether, what about converse? Is converse true? Okay, so definitely converse is not true, because you can show or you can give examples of a sequence which are bounded but they are not convergent. Okay, for example, you can, usual sequence we can take. So we can say here bounded sequence need not be convergent. Need not be convergent. Right? You can give example, minus 1 raised to n. For example, minus 1 raised to n is bounded. Why bounded? Because if you consider terms of this sequence, write it as a set. Range set of minus 1 raised to n is having just two terms, 1 and minus 1. So it is bounded set, right? So sequence minus 1 raised to n is bounded, but we definitely know, but it is not convergent, right? It is not convergent. So I hope you are clear with this particular idea, that every convergent sequence is bounded but the converse is not true. Okay, so we will stop at this point. We will continue the lecture, means to continue this concept in the next lecture also. Thank you.